This chapter focuses on the bones of the limbs and the bones that connect them to the body. The appendicular skeleton includes the bones of the limbs and the supporting elements or girdles that connect them to the trunk. The appendicular skeleton allows you to stand, walk, write, turn pages, eat, dress, shake hands, wave, and any other things you do with your arms and legs. It is your appendicular skeleton that lets you manipulate objects and move from place to place. The appendicular skeleton is dominated by the long bones that support the limbs. Each long bone has two epiphyses, and one of the epiphyses at one end of the bone will be called the head of the bone. The diaphysis is called the shaft, and the neck normally separates the head from the shaft. For example, the upper arm bone called the humerus will have the head of the humerus or the humeral head at one end. Each arm articulates or forms a joint with the trunk at the pectoral girdle, otherwise known as the shoulder girdle. The pectoral girdle consists of two S-shaped clavicles or collarbones and two broad flat scapula or shoulder blades. The medial end of the clavicle directly articulates or connects with the manubrium of the sternum. This is the only direct connection between the pectoral girdle and the axial skeleton. Only skeletal muscles support and position the scapula, with no direct bony connections or ligaments connecting them to the thoracic cage. As a result, the shoulders are extremely mobile, but not very strong. Movements of the clavicles and scapula position the shoulder joints and provide a base for arm movement. The surfaces of the scapula and clavicles are important sites for muscle attachment. Bony ridges and projections on the bones mark the attachment site of major muscles. The clavicles are S-shaped bones that originate at the superior lateral border of the manubrium of the sternum, lateral to the jugular notch. The clavicle then curves to form an articulation with the acromion, which is a projection on the scapula. The acromial end of the clavicle has a rough inferior surface where ligaments and muscles attach. It is easy to distinguish a left from a right clavicle once you know which end of the clavicle is the medial end and which side of the clavicle is inferior. The scapula has a body which is on the anterior surface. The body is bordered by three sides in the shape of a triangle: a superior border, a medial border, and a lateral border. Muscles that position the scapula attach along these edges. The corners of the triangle are called the superior angle, the inferior angle, and the lateral angle. The lateral angle, or head of the scapula, forms a broad process that supports the glenoid cavity. At the glenoid cavity, the scapula articulates with the head of the humerus, which is the bone in the upper limb. The anterior surface of the body of the scapula is smooth and concave. This depression is called the subscapular fossa. The two large processes that extend from the scapula just superior to the head of the humerus are called the coracoid process, which is smaller, and the acromion, which is larger. If you run your fingers along the superior surface of the shoulder joint, you will feel this process. The acromion and the clavicle articulate at the acromioclavicular joint. Ligaments of the shoulder joint are attached to both of these projections. On the posterior surface, the scapular spine is a ridge that crosses the posterior surface of the body. The scapular spine divides the posterior surface of the scapular body into two regions: the supraspinous fossa, above the spine, and the infraspinous fossa, beneath the spine. The skeleton of the upper limbs consists of the bones of the arms, forearms, wrists, and hands. The term arm refers to the upper limb from shoulder to elbow. This is also called the brachium, which consists of one bone, the humerus. The forearm, or antebrachium, consists of two bones, the radius and the ulna. This is the anterior surface of the humerus. At the proximal end of the humerus is the round head that articulates with the glenoid cavity of the scapula. The prominent greater tubercle is a rounded projection on the lateral surface of the epiphysis. This tubercle forms the lateral contour of the shoulder. The lesser tubercle is smaller and is medial to the greater tubercle. The groove in between the greater and lesser tubercle is the intertubercular groove, where a large muscle tendon runs through it. Both tubercles are important sites for muscle attachment. Lying between the tubercles and the head of the humerus is the anatomical neck. The joint capsule begins at the anatomical neck. The narrower, more distal surgical neck corresponds to the metaphysis of the growing bone. It is named surgical neck because fractures typically occur at this site. The shaft of the humerus has a large, rough elevation on the lateral surface called the deltoid tuberosity. This elevation is about midway down the shaft and is where the deltoid muscle attaches to the humerus. Near the distal end of the humerus, near the forearm, the shaft of the humerus expands to either side at the medial and lateral epicondyles. Epicondyles are processes that develop proximal to an articulation and provide additional surface area for muscle attachment. The condyles of the humerus are where the humerus articulates with the radius and the ulna, the two bones of the forearm or antebrachium. The trochlea is the spool-shaped portion of the condyle, and the capitulum forms the lateral rounded surface of the condyle. On the anterior surface of the humerus, just superior to the condyles, is an indentation called the coronoid fossa. On the posterior surface of the humerus is a large indentation called the olecranon fossa. Projections from the ulna bone in the forearm fit into the olecranon fossa as the elbow approaches the limits of its range of motion. The prominent medial head of the humerus and the differences between the medial and lateral condyles make it easy to tell a left humerus from a right humerus. The ulna and radius are the two bones of the antebrachium or forearm. These bones are parallel to each other. In the anatomical position, the ulna lies medial to the radius. The olecranon is the proximal end of the ulna and is the pointy tip of the elbow. The interosseous membrane is a fibrous sheet that connects the ulna to the radius. Near the wrist, the ulna narrows before ending at the disc-shaped ulnar head, or head of the ulna. The posterior lateral surface of the ulnar head has a short styloid process. The distal ulna articulates with the radius at the distal radio-ulnar joint. The radius is the lateral bone of the forearm. At the proximal end of the radius is the radial head, which articulates with the humerus. A narrow neck extends from the radial head to the radial tuberosity, where the biceps brachii muscle attaches. The shaft of the radius curves along its length. At the distal end, the shaft enlarges, and the distal end of the radius is much larger than the distal end of the humerus. The styloid process of the radius is found on the lateral surface of the radius. The styloid process helps to stabilize this joint. The carpus or wrist contains 8 carpal bones. These bones form 2 rows, one with 4 proximal carpal bones and the other with 4 distal carpal bones. There are 5 metacarpal bones that articulate with the distal carpal bones and support the hand. Roman numerals 1 through 5 are used to identify the metacarpal bones, beginning with the lateral metacarpal bone. Metacarpal 1 articulates with the proximal bone of the thumb. Distally, the metacarpal bones articulate with the proximal finger bones. Each hand has 14 finger bones or phalanges. The first finger bone, or the thumb, is known as the pollex and has 2 phalanges, proximal and distal. Each of the other fingers has 3 phalanges, proximal, middle, and distal.